So we will take one more problem of this, and then we'll take a special problem, what is called a projectile motion problem. Right? So let me put you on another problem here. The particle moves along a curved path. The path of the particle is given by y equals 0.4 x square. So it's a parabolic path, very straightforward. At x equals 2 meters, at x is equal to 2 meters, its speed means the magnitude of velocity given is 6 meter per second. Its speed, look at this word, speed, that means it is velocity magnitude at x equals 2 meters. And it is increasing, this velocity speed is increasing at 3 meter per second square. So look at increasing at the rate 3 meter per second square. So if the speed is increasing with some rate, means what is this acceleration? This acceleration is tangential component of acceleration. That's given because speed is increasing. This component of acceleration is what is responsible. So given 3 meter per second squared is AT. That you have to understand. So now what is the question? At this instant, what do you mean by at this instant? And when x is equal to 2 meters, determine A, velocity vector. Number 2, acceleration vector. This all quickly should be solved because you understand. See now what is given here is the path equation. Right? So you are given y equals 0.4 x square. So if you look at this path, it would be a parabolic path. This is x and this is y. When x is 0, y is 0. When x is 1, y is 0.4, and x is 2, 0.4 into 4, and so on. So this path will go something like this. Right? So in this, when x is 2 meters, you are given the data. So if I project this, I'll have this point. The speed is 6 meters per second, right? And it is increasing. That means this particle moving in this path is accelerating. Acceleration, that's important because it's increasing in its magnitude. So accelerating. So if that is so, what is my velocity vector and acceleration vector? So let me draw my velocity vector. It is always tangential. So my velocity vector is this. So if I extend this, this is a tangent here. So this is my velocity vector. What is my acceleration vector? An acceleration vector will always lie on the curvature side. So this is curved in this fashion. My acceleration vector. So AT is responsible for this V to increase in the next instant. Previous instant, the length of this vector is smaller. So it is in this. So I would have my acceleration vector maybe in this direction. So I will have its component 1 along with this. That is AT. Another one is along with this. That is AN. And if I combine these two, what is that I have is A vector. This is my A vector, right? So you are given this AT is what is given as 3 meter per second square. I do not know what is AN. If I know AN, I know what is my A vector, and this vector should be represented in a Cartesian coordinate form. So I in J form I have to represent. So I can find what is my A, and this I can find. So now how do I proceed doing it? What is that I require now? I know my velocity is tangential. So if I know this angle theta, I have already my velocity vector, right? So I have already my velocity vector. So how do I get that now? I have my velocity vector. So how do I get that? For that I require the slope. This is nothing but dy by dx. So this angle theta is tan theta, right? Sorry. The angle is theta, then tan theta is what is dy by dx. And I know path is 0.4 x square. So dy by dx is 0.8x, and dy by dx at x is equal to 2 meters is what I wanted. So 0.8 into 2 is 1.6 meters. It's a slope, right? So no unit. Don't put the unit. So it is 1.6. So now I know what is my angle theta, tan inverse of 1.6. So that's going to be 1.6. Shift to tan inverse 1.6 is 58 degrees. 58 degrees. 57.999. So 58 degrees. So this angle is 58 degrees. I know my velocity vector v is given by 6 meters per second. Right? V is 6 meters per second. Given. So I can write my velocity vector at x is equal to 2 meters as 6 cos 58 degrees I plus 6 sine 58 degrees J. So that's going to be 6 into cos 58 degrees, that's 3.179. So 3.18 I plus 6 into sine 58. That's 5.088. So let me write 5.09 J. So this is my velocity vector. So if I take modulus, it is equal to 6. So now what is my acceleration? So already I have one component of acceleration given in the problem, 3 meters per second square. I have to get what is my AT. So how do I get my AN? How do I get my AN? This AN. So we know this AN is given by V squared by rho. So if I know rho at x is equal to 2, so rho is not constant. It is not a circular path to have rho constant. It is a parabolic path. So you will have your rho is varying, right? So the rho will be minimum at this point because it is the more curvature point, and as it is going, the rho value will be different. So you have to find the rho value. So how do I get the rho value? Since the path equation is given, it should strike to me that I can get my rho value equals 1 plus dy by dx whole square over 3 by 2 by d square y by dx square. So I have already dy by dx at x is equal to 2 is 1.6 found out. So what is my d squared y by dx square? That is 0.8. So I have that value. So I can substitute that 1 plus 1.6 square power 3 by 2 by 0.8. So that's going to be 1.6 square plus 1, 3.56 to the power 3 by 2, so 1.5, 6.72 divided by 0.8. So it is 8.396 meters. 8.396 meters. So that's rho at this position. So now I know what is my AN, right? So I got what is my AN. Therefore, AN is V square. So 6 squared by 8.396. So that's going to be reciprocal into 6 square. 4.2876. So let me rewrite that as 4.288 meter per second square. Look at the unit, we have to be very careful. It's acceleration. So I have an. So this is my what component? An component. At component is given. That's increasing at the rate of 3 meters per second. 3 meters per second square. Therefore, my A vector would be what under root of at squared plus an squared. So if I substitute, that's 3 squared plus 4.288 squared. What is that I have? This square plus 3 squared, the root of this answer. So 5.233 meter per second square is what is my total acceleration magnitude. And where is it acting now? It is acting in this direction. So how do I put my direction for that? So if this is the path at this point 2 meters, I have my acceleration vector is this. So the theta will be tan inverse of an by at if I put. So what is this theta corresponding to that? So it's not this slope. So I have my normal here, and I have my acceleration vectors now. This is my at, and this is my an, and I compose this. When I compose, I get my total acceleration A. And what is its direction? I am finding out is to the tangent. What is the angle to the tangent? This is theta. Right? So this angle theta I am finding out. So this theta is now tan inverse of opposite an by at. So that's going to be tan inverse of an value is 4.288 by 3. So it's 4.288 divided by 3.
55.
Yeah. So 55.02 degrees. 55.02 degrees. So what is this theta? So now what is direction of my total acceleration? To the tangent or to the velocity. So always remember this direction of acceleration to the velocity vector we should represent by default, not to normal. So to the normal mean 90 minus this, so this angle. But the default always we represent acceleration direction to the velocity in a curvilinear motion. So that would be tan inverse of an by at. So you have got this. So already this angle now we found out, that is theta corresponding to velocity, and this is theta corresponding to acceleration. So theta corresponding to velocity we found how much it is, 58 degrees. Therefore this acceleration vector to the horizontal 58 plus this, so it is suppose this is that from horizontal if I represent, this is not a correct diagram. So this angle appears to be 90 degrees, but it is more than that. So if this is the point of observation, say O, at that point I have this angle. So this is my A vector, and this is 55 plus 58 plus 58. So it's 113.02 degrees to the horizontal A vector at that instant. So this is how you can predict its motion parameters. So these are some sample problems. Please look into